Good day everyone. Today I will be presenting our work, What do blind and low vision people really want from assistive smart devices? Comparison of the literature with a focus study. I'm Banuka and this work is done in collaboration with my supervisors Tuan, Nick, Arthur and Kim. I also want to thank the Monash Data Futures Institute for funding this project. So without further ado, let's dive into the presentation. So the presentation will have three main sections. First, I will explain the motivation behind the research, then move on to the methodology, where I will discuss the two stages of the study. Finally, I will discuss the four main findings from the research. So, why did we do this study? Before we get to that, let me define a few terms that we used in this study. Firstly, we define smart devices as personal assistive technologies that use AI-based computer vision to help an individual understand their surroundings. These might be smartphone applications, standalone devices, or wearables. Tasks are defined as the tasks that these smart devices can perform to help BLV users. This can be as simple as detecting a wallet or as complex as guiding the user to buy their groceries. We discovered that there are hundreds of papers that discuss smart devices using computer vision designed for BLV individuals. Several authors have evaluated these devices aiming to compare them as part of review papers. However, only a few papers have specifically looked into the needs of BLV users. The most relevant research comes from Golubawa et al. They asked the participants to wear recording glasses that can be turned on to capture a moment where they would use a perfect sight aid. However, as of now, there has been no comparison between the tasks and smart devices that researchers have focused on and the needs of BLV people. So the main question we aim to ask is, does current research in smart assistive technologies address the needs of the BLV users? And if not, what needs should researchers address? To do this, we conducted a two-part study. We began our investigation by looking through existing literature to figure out the different tasks and smart devices that researchers have been studying. We performed a scoping review and found a total of 646 papers from 2020 up to middle of 2022. From each of these papers, we pulled out four key pieces of information. First, the task. Next, the type of smart device used in the study. Then, the interaction model, which refers to the high-level interaction model from the user's perspective. For example, this could be image enhancement or detecting and recognizing objects that users asks about. Finally, we determined if BLV individuals were part of the study. If they were, we also noted whether they were involved in the design phase, the evaluation phase, or both. For the next phase of our research, we conducted 24 semi-structured interviews. We guided participants through three main objectives. We inquired about their current technology usage, the most useful tasks, and we asked the participants to rank the various tasks that researchers had focused on. Afterwards, we collated the results from the scoping review and the interviews and reported four main findings. To begin, we uncovered a weak positive correlation between the tasks researchers focused on and the importance given by BLV participants. This implied that not all tasks that the researchers were focusing on held the same level of importance for the participants. We highlight certain tasks that researchers could focus on. We divide this into two categories. In emphasis on category, you'll find tasks that participants ranked higher but less work was done on. These are tasks such as fill paper forms, aerial obstacle detection, shop recognition, safe navigation space detection, bus door detection, and thermal hazard detection. In the new category, you'll find tasks that participants considered important but hadn't been explored by researchers. These are tasks such as empty seat detection, sorting and organizing items, checking the appearance, and noise detection. We also found that participants expressed a preference for a universal device or platform. According to them, if a task can already be accomplished using an existing device, there's no necessity to create a separate device just for that task. Next, our study also concluded that researchers should place greater emphasis on head-mounted devices. We found that they are hands-free and follow the natural gaze of the user. Additionally, participants brought up an intriguing idea: devices that could be mounted on guide dogs. This particular form of device wasn't previously seen in the literature. Next, in terms of interaction, all participants said they prefer conversational agent type devices, where they can ask questions from a device and it will use the camera to understand the context. Finally, the most important finding was 82% of the studies from our scoping review did not involve BLV participants. Not only that, only 38 out of the 646 studies had participants in the design or requirement gathering stage. These were devices that were designed to be used by BLV individuals. We strongly believe that it's crucial for researchers to understand the significance of engaging BLV participants right from the start of the research journey. This is just a summary of the findings of our work, and we recommend reading the full paper to understand the exact procedures and findings from the study. Thank you very much for listening to our presentation. Please feel free to reach out for any questions.